Hi, this is Alex from devstories.eu. SunPy, Solar Data Analysis, Episode 4 of 12. You spot a massive flare on the sun, record its horizontal and vertical coordinates, and send them to a colleague. But their telescope is parked on a satellite trailing halfway behind the Earth, and your coordinate numbers mean absolutely nothing to them. That is because a point on the sun is not a static dot on a flat grid. Its position depends entirely on where your telescope is parked in the solar system and exactly what time it is. The way we resolve this ambiguity is through coordinate frames and observers. It is a frequent mistake to define a point on the solar surface by simply passing two numerical values into a variable. You must explicitly name the context. Without providing an observer location and an observation time, a solar coordinate is physically meaningless. The solar system is constantly moving. The Earth orbits, probes drift along their trajectories, and the sun itself rotates. To safely define a location in this dynamic environment, SunPy uses an object called SkyCoord, inherited from the Astropy library. A SkyCoord acts as a strict container. It takes your raw numbers and binds them to a specific physical frame of reference, forcing you to define both space and time. The most common frame you will encounter is the helioprojective frame. This frame describes the sun exactly as it appears to a specific camera lens. It is a two-dimensional projection of a three-dimensional sphere, measured in angles like arcseconds. It essentially measures lines of sight from the observer to the solar disk. Because it is fundamentally tied to the observer's vantage point, creating a helioprojective coordinate requires you to supply the observer parameter, which defines where the telescope is, and the obs time parameter, which locks in the exact moment the shutter clicked. Contrast that with the heliographic Stonyhurst frame. This is a true three-dimensional coordinate system that uses solar longitude and latitude. It is intrinsic to the sun, but spatially fixed to the solar system layout. The 0-degree longitude line of the heliographic Stonyhurst frame is locked so that it always points directly at Earth. It gives you an absolute physical location on the solar surface rather than a localized viewing angle. Here's where it gets interesting. Let us walk through how you would translate between perspectives. Suppose you have a SkyCoord for that solar flare recorded from Earth using the helioprojective frame. You want to figure out exactly where a spacecraft orbiting Venus would see that same flare in its own cameras. First, you instantiate your original SkyCoord with the Earth observer, the observation time, and the arcseconds. Next, you retrieve the physical location of Venus. SunPy includes built-in functions to look up planetary trajectories for a given timestamp. Once you have the coordinate for Venus at that exact observation time, you call the transform method on your original Earth coordinate. You pass this method a brand new helioprojective frame, but you set the observer parameter of this new frame to Venus. SunPy then runs the complex three-dimensional geometry under the hood. It calculates the physical lines of sight and returns a new SkyCoord. This resulting object contains the exact angular coordinates the flare appeared at from the viewpoint of Venus. The most critical insight to take away is that a solar coordinate is never just a location. It is a strict relationship between a target and an observer frozen at a specific millisecond. That's all for this one. Thanks for listening and keep building.